Dear students, welcome back again. My name is Johannes. In this lecture session, I'm going to show you some basic principles of the most efficient and economical channel cross-sections. So the main objective of this topic is to determine the flow velocity, depth, and flow rate for a given hydraulic parameters. And the roughness of a channel, we can have some design. So the designer for this given discharge slope and roughness, the designer aims to minimize the cross-sectional area of a channel in order to reduce cost of construction. So we will just assume this. So a channel is said to be the most efficient and economical cross-section if the weighted perimeter is minimum. If the weighted perimeter or weighted perimeter of the channel is minimum for a given discharge, so it is efficient and economical, and cost of construction and lining cross-section are minimum again. And also, if the discharge is maximum for any given cross-sectional area, and also the velocity V is maximum for the minimum cross-sectional area, and the semicircular section having its center in water surface is the best hydraulic section. So having this in mind, we will consider for any given discharge flow rate or velocity and bed slope and Manning roughness or Chasey resistance coefficient. So we will have minimum weighted perimeter for any given discharge, and also cost of construction and lining should be minimum. Cost of construction and lining also minimum, and discharge should be maximum for any given cross-sectional area. So let us start now. Case 1, rectangular channel. When we take rectangular channel, so you have bed dimension B and depth Y. So we have area of the cross-section is B times Y, and the perimeter is B plus 2Y. So Y here also Y, so B plus 2Y. Then from equation 1, from this one, you can take B A over Y. So substitute in the second equation in this one, A over Y plus 2Y. So this is the third equation we are going to analyze. So for maximum discharge, P should be minimum, perimeter should be minimum. Then you have this equation. This is dP by dy should be equal to 0. So to get minimum value with respect to y, we have to differentiate d with dy, which is this equation, a over y plus 2y equal to 0. So if you just derive it, you know this equation from calculus. If you have a fraction or any two functions, just division, so f derivative g minus f g derivative over g square. We can apply this equation. Then, having this in mind, you have this is a constant, so f derivative g will be 0, then minus f will be a, g derivative will be 1. So minus a over y square plus 2. So this is a derivative. So just calculate area now from this equation. You get this equation. So this is the area. The area should be this equation to find minimum weighted perimeter for a given maximum discharge. And if you substitute again area 2y square in this equation, then you can find B. B will be 2y. Then weighted perimeter again, you substitute simply here. B is equal to y, 2y plus 2y will be 4 times y. Then hydraulic radius is area over weighted perimeter. So if you divide area by weighted perimeter, you will find y over 2. Then the rectangular channel is the most efficient and economical cross-section when the depth of water is half of the width of the channel. Depth of water half of the width of the channel, or the hydraulic radius is half of its depth. So this is for a given maximum discharge. You should have these equations. Okay, second case is trapezoidal channel. So in trapezoidal channel, we have this cross-sectional area. This is a cross-sectional dimension, bottom dimension and inclination 1 to m, and side length is y square root of 1 plus m square. This is a depth y. So since this is right angle, so you can find y square plus m y the whole square equal to this one. Then take out y common, then it will be y square root of 1 plus m square. So these side lengths. So we have geometric parameters or geometric elements of the channel, such as area b plus my times y. Then you can just rearrange this equation. B is equal to a over y minus my. So over y, you divide over y on both sides, so you get this equation. Then perimeter again, b plus 2y, this is b plus 2y square root of 1 plus m square, square root of 1 plus m square, because you have side lengths y square root of 1 plus m square on both sides. So this is the perimeter. Then you substitute this b into this equation. Then we will have again top dimension is b plus 2my. Then after substitution, we will just derive it. So this is again hydraulic radius. You can apply this equation. Now let us substitute instead of this one, dp by dy should be equal to 0 for minimum. For most economic cross section, that is maximum discharge, p is minimum for a given side slope or m. This is side slope. So just derive d with respect to dy, which is p. This is p equation. So we are going to differentiate. So if you differentiate, again the same approach, negative a over y square minus m plus 2. This is y is the power of 1. Then this is a constant equal to 0. Then you can find a, you can solve from this equation. A will be this one, 2 square root of 1 plus m square minus m the whole y square multiplied by y square. Then b again, you can find 2y times square root of 1 plus m square minus m. So this is b. If you substitute in this equation, you can find this one. Again, perimeter, again, you substitute here, then you will find this equation. So if you have side slope, then you can automatically calculate area, bedwidth, and perimeter automatically by substitution in place of this. But y should be given. Then finally, you can find the most economic channel cross section. And top dimension is b plus 2my. Then 2y square root of 1 plus m square. You can find the same. Then hydraulic radius is area over weighted perimeter. Using this equation, you bring this equation. Then you substitute all parameters. Then finally, you can find y over 2. Okay, for a given depth y, what will be the side slope m? The side slope m for best trapezoidal cross-sectional area, p is minimum. Then if m is not given, then you have dp by dm equal to 0, dA by dm equal to 0 to get maximum discharge and minimum weighted perimeter. So you simply substitute again d by dm, just d by dm, which is dp, perimeter already calculated in the previous slide. So you can substitute automatically this one, equate to 0 in this equation. Then you have this equation. So the same approach, you have a over y, then you can derive it with respect to dm. So dA by dm, this is the first f derivative, dA by dm times g, which is this one, y, minus f derivative g over g square. G square is this one, then minus y, this is, it comes out to be minus y. And this is, you have radical, so radical derivative, you can just calculate 1 over 2 radical square root of 1 plus m square over times 2m. Inside the radical, you have square. So you have 2m. Then you found this equation. You can cancel y on both sides. Then finally, we get this expression. Then solving the above equation, we will find m is equal to 1 over root 3. So m should be root 3 over 3 or 1 over root 3, which means m is tan theta, which is equal to 1 over m. Then theta will be 60 degree. So this is 60 degree inclination to get minimum weighted perimeter and maximum discharge. Then you simply substitute this value in the above equations. So area will be root 3 times y square. Automatically, you can substitute. Then p is equal to 2y root 3 again. Then b is equal to p over 3. Then finally, top dimension will be 4 root 3 over 3 times y. Then b again 2 root 3 over 3 times y. So we are just substituting the value of this one, which is m 1 over root 3 or theta 60 degree. Automatically you can find area, perimeter of the channel, bottom dimension, top width, and other bottom dimension with respect to y. Okay, the third case is triangular channel. So in triangular channel again you have this one with side slope 1 to m. So this is the right angle. So you have y depths, here y depths, then my. Then you can find area of total. So area will be half of 2my times y. So it will be 2 will be cancelled out. So area will be area of the triangular channel is my square. Then from this you can find y. Y will be a over m, the power of half. Then t will be 2my. Top dimension is my plus my. You can find 2my. Then perimeter is just the side slope, which is a summation 2 times y square root of this one. So this is the perimeter. So for a given depth y, find m. For what value of m you can find so that weighted perimeter is minimum. So you can just square both sides. This one, you can square both sides. Then finally, you can find this equation, which is this one, will be just you have 2 times a over m. You substitute in place of y. Here, the value of y is this one. Then you substitute. Then you have this one. So you can just square both sides, squaring both sides. Then it will be 4. A will be cancelled out. Then a the power of half will be cancelled out. This radical will cancel out. So this is the equation for p. Or you can make again square both sides. So p square equal to 4 times a over m times 1 plus m square. So this is the general equation. So once you have this equation, this is the equation. Then to make simple, which is exponents, so derivate both sides with respect to m. If you derivate, so this is 2p here, 2p, then dp by dm equal to, this is a constant, which is 4a, then 1 over m, derivate, negative 1 over m square plus 1, this is 1, equal to 0. So from this, you can just solve this equation, which is m square will be 1. Once you get m square equal to 1, then m will be 1. So the side slope should be 1 to 1. So once you find this one, then tan theta means this is the inclination angle. This is the tan theta. Then tan theta is opposite over adjacent. So my over y. So y cancel out. So you have tan theta is m, which is 1. So it will be tan inverse of 1 will be theta should be 45 degree. So once you find 45 degree, then finally, automatically you can just calculate by substitution all other variables can be found. Area will be equal to y square, and also top dimension equal to 2y, and perimeter will be 2 root 3 times y, and hydraulic radius will be y over root 2. Y over root 2. So this is just by substitution. You can find. Okay, case 4 is just a circular channel. Circular channel. For circular channel, you have y depth, which is partially full, and diameter you have up to the crown level of the circular channel, you have d. Then we have area, d square over 8, 2 theta minus sine 2 theta, and also p is equal to d sine theta, and this is the general equation from the previous uniform flow equation, and cos theta is this one. So I hope the proof, let me show you with the other format. With the other format here. With the other format. So this is a circular channel. Now let us see. You have hydraulic radius. Hydraulic radius is this one. Hydraulic radius is this one. So from hydraulic radius, we can find area divided by weighted perimeter. So area is already known from this above, which is d square over 8. Then you have this equation. Then for maximum discharge, what will happen? For maximum discharge, how do you compute? So for maximum discharge, for maximum velocity, first let us see for maximum velocity. For maximum velocity, which is dr, which is hydraulic radius with respect to d theta, should be 0. So if you differentiate this one, then theta will be this result. So this is the result for maximum velocity. So y will be, you can substitute now in place of theta. So y will be 0.81 times diameter, and radius will be 0.3 times d. And for maximum discharge, we can follow the same approach, which is for maximum discharge, again, we have this equation, d with respect to d theta, square root of a cube divided by p, which is this one. So you will find t is equal to this one, and top dimension will be 2 times y, r will be y over 2, and theta will be 154. For maximum discharge, theta should be 154, and y will be 0.95d. And using Chase equation, you can find this equation. Using Chase will be changed. So I think we can compute such equations. Let us summarize. So best hydraulic sections. So the conveyance of the channel section increase with an increase in the hydraulic radius, or with a decrease in the weighted perimeter. So this is very a key issue in hydraulic section, in best hydraulic section. So with an increase in hydraulic radius, or with a decrease in weighted perimeter, we can just increase the conveyance, or just the efficiency for maximum discharge. So these are just a summary table. You can see rectangular channel, area, weighted perimeter. Again, if m is not given, what will happen? Let us see. If m is given, or if m is not given already, we have solved many calculations here in the above. Here, if m is given, if m is not given. So let me summarize now. Summarizing the table. So trapezoidal channel root 3 y square. If theta is, or if m is 1 over root 3, you substitute, then area will be this one. Perimeter will be 2 root 3 y, 4 over 3 root 3 y, y over 2, 3 over 4 y. This is hydraulic depth, and this is section factor. So triangular channel, which is half of that square, y square, etc. You can proceed. And also circular channel, you can see this one for maximum discharge and for maximum velocity. You have to keep these results, and then for parabola again, we can derive. Okay, so for most economic trapezoidal section, if M is given, which is M horizontal, 1 vertical, so you just the weighted perimeter should be minimum, so dp by dy is equal to 0. So we find this one area, bottom dimension, perimeter, and also perimeter and top dimension and hydraulic radius. So these are the basic equations for side slope if it is given. So we differentiate dp by dy and equate to 0. So we found these results. If m is not given, so you simply dp by dm equal to 0. Then we found 60 degree or root 3 over 3. Then after substitution, we have these equations. So area should be root 3 y square, and also perimeter should be, weighted perimeter should be 2y root 3, and top dimension 4 root 3 over 3 times y, and also bottom dimension p over 3, 1/3 of the perimeter, and or 2 root 3 in terms of depth. You can use this equation, and m is already known after differentiation. So r will be this one. So I think with this, we will just proceed some examples. And thanks for watching. This video. So this is all about today's lecture. Hopefully you liked the video. If you have any comment or question regarding this topic, please write down in the comment section below. I will reply on it. Please like, share, and subscribe this video to get more precise lectures. Thanks.